Hello and welcome to another episode of the Post Cloud Podcast, where we talk about all things cloud, cloud technology, security, etc., all the things around related to cloud and what is happening next in the cloud industry. My name is Chris Krantz. I've been working in cloud with cloud native technologies for a number of years now. I'm joined by my co-host Stephen.
Hi, Stephen Howell. I've been working as a systems engineer, systems architect, and lately automating a lot of Kubernetes stuff. And we're pleased this week to be joined by Nic, who's going to be talking to us about lots of interesting access control systems and mapping your assets and considerations for using Kubernetes in all sorts of new and interesting ways. Hello, Nic.
Hi guys, very happy to be there. So yeah, I'm Nick. I've been in this industry probably for too long. Over 20 years now, doing a lot of things from data center, networking, virtualization. Now, yeah, cloud native for the last 6, 7 years, doing DevRel for the last three years.
Cool. So let's jump in and talk a little bit about IAM, so identity and access management, and some of the challenges of that and some of the other aspects of IAM and what it means to developers. Let's jump in. We introduced Kubernetes in the previous episodes where we talked around the idea of orchestration and the need for that. But one of the challenges is then what permissions does Kubernetes need internally to talk to its own components, for applications to talk to each other? And obviously, applications don't always exist in isolation. You'll have these external dependencies. And I'm assuming you're going to need to make sure you've got some permissions there. So I don't know if, Nick, you can kind of talk around some of the challenges that we face.
Yeah, sure. I mean, it all starts, I believe, with the developers because typically this is the people who needs access to these resources, and only them know what are the components talking together. So there's actually distinct work to be done here. There's the security team, who obviously as the number of security domains that needs to be controlled by the platform team and configured by the developers teams. They need to have sort of zero trust approach. Zero trust don't necessarily mean that you don't trust anyone. It just means that the perimeter that we used to know. Typically, remember we had a DMZ, we have internal, we have external, we have internet. Now, the concept of zero trust is that let's consider if everything was in the public internet. So this is typically what we have to face today with microservices application that needs to access different resources in the cloud or in another environment, all those sensitive data. So the challenge is if you put all this cognitive load on the developer, the risk is misconfiguration that ultimately will lead to security breach, and basically we are increasing the blast radius in case of failures. And all these developers, they not physically able to know all this new concept from IAM roles in AWS work differently compared to Google, Azure, or if you have any local components also with special credentials.
In fact, I remember the credentials operator being a huge help because trying to tell developers that they had to follow a set of rules to create TLS certificates for each and every application turned out to be impossible. And along came the Kubernetes credential operator, and suddenly developers can just get a correct certificate, which was really useful for us.
You have the knowledge with developers, you have the constraints within security, and you have the platform team in the middle who's trying to keep the lights green all the time. Yeah, I think this is the challenge, how to make everyone happy, because the more security, the less innovation, the longer the sprint cycles, and there's a lot of friction there.
Definitely seen over the past couple of years, security is more and more involved in development life cycles, and often becomes a blocker, or at best or at worst becomes a blocker. At best, it just slows down.
I'd go even further and say security at best could be a blocker in terms of a problem, and at worst you try and pretend it doesn't exist, and then you release something and get a rude awakening after release, and that can be quite reputationally damaging.
There's two risks. The first risk is that you don't deliver a feature in time, which may impact your customer base. but not that much your reputation. If you have a larger breach that is impacting, exposing some of your customers' data on the internet, then it will obviously, touch your reputation, impede your reputation. Plus, you will lose that customer, but so many more after that. So, yeah, I think security is the first mandatory rule. Like, you don't want your name in the newspaper. That's rule number one. Rule number two, you want to keep producing code to foster innovation, obviously. So you have to find the right balance.
And because there's very few incentives other than risk, like no one's giving you a trophy for best security ever. What's really key here is to try and make it easy to adopt, right? You can't send everyone on a 2-week course to learn security. So what does the intent-based approach that we're looking at here have in terms of ease compared to typing out traditional ACLs?
So, here what we can see is what we call a client intent, which is a custom resource in Kubernetes. So you can see under the calls section, there are a couple of names there. So you can see, so it's under the, from the perspective of the client. So here the client is basically the name. So that it's coming from a broader application, which is a joke generator. So here we are in the shoes, let's say, of the joke worker. And the job of the joke worker is to call the OpenAI API to generate a joke with chat completion, to store it into DynamoDB, into a Redis cache as well. And it's also listening for NATS messages for joke requests. So it's going to subscribe to those messages and then send the message back with the joke. So effectively, we need to access multiple services there in different places. So calls, we need to connect to NATS. So I need access to NATS. I need access to Redis. I need access to internet site, websites. So api.openai.com. I need to access to the DynamoDB region, and I need to access to my STS service to get my short-lived credential to assume the role. And then I need access to the DynamoDB itself. So this is the identification here, the RN of my jokes table. I need basically also the DynamoDB permissions star, which means I can read, I can write on that particular database. So it's basically, as a developer from the joke worker, this is what I need to make my service work, to make my joke worker work. This is the intent I need. But what it's going to do in the backend, how is it going to be translated? So here, everything that is just a name will be translated into a network policy, right? So we're going to enable access to NATS, access to Redis, but in the context of those services, right? So we're going to create ingress rules into this target namespace. So even though the client intent is from the client perspective, we don't change, what you would do in a firewall. So in a firewall, you would say, okay, in my vision, I'm allowing ingress connections. Here, it's the same thing. I'm expressing my client intent, which is essentially egress, but we're going to configure that from an ingress perspective, right? So network policy for NATS and Redis. For internets, and this is the part I probably like the most. So here it's FQDN, it's domain names, but network policies, it's only working with IP addresses, IP CIDR, except if you're using another CNI that one like a Cilium or maybe Calico, who have special network policy, right? It's not Kubernetes native policies. It's their own network policies. So here, what you can do with this client intents, so I didn't mention, but client intents, behind the hood, there's a couple of operators that are helping to make this happen. So typically, to translate those rules, we are talking about something that is called a network mapper, to translate DNS into IP addresses. So we're going to monitor the IP address, we're going to resolve that into DNS name, and if whatever IP changes, we keep the same DNS name, but effectively in the network policy, we're going to update the IP addresses there. So we maintain this binding between the DNS and the IP that are resolved, and constantly updating the resources inside Kubernetes. So you don't need to mention DNS name in the network policy because it wouldn't work, but you do it in the client intent, the higher abstraction level. And then and this is why you have STS, DynamoDB, and API.openai.com and not the IP address. And you don't, as a developer, you don't even have to know that you are accessing those services. The network mapper will detect the egress calls and resolve that for you. So it's going to tell you, or to begin with, your application we noticed that it's accessing those websites. Do you want to allow them? Yes, no. Okay, so it's going to generate this client intent automatically for you, and then you can copy paste in Kubernetes or just apply them directly from the recommended manifest. So there's two ways to do it. Either you already know what DNS names you need, or you don't, and you just let the network mapper figure it out for you. And the last part, so this is if you type, if you type internet. And the last one, which is type AWS, in that particular case, by mentioning the ARN and the permissions you need, so only two things. So we are going to configure IRSA, so IAM role for service account, which is essentially a way to configure IAM roles from Kubernetes. But for that, you need a lot of different components. You need, first, you need to enable the OIDC provider in EKS. You need to create the IAM roles. You need to create a trust relationship. And then you need to create your policy. So there's a lot of things you have to do. By doing just that, it's doing everything for you. So you just specify the intent, which is I need to access that specific resource in AWS. This is the permissions I need, period. Apply this client intent, and then it's going to configure everything into AWS for you.
So you've made security accessible. Instead of having to write a long-form firewall rule with port numbers and IP addresses, you've got a tool here that's able to do that easily with DNS names. And you don't even have to discover the DNS names yourself. The tool is running in a non-enforcing mode to start with, writes you a report on what you're doing, and you could double check that and say, yes, that is what I meant to do, or no, wait a minute, what's this other app that I'm calling that I shouldn't be able to call? There's some errant piece of code. I'm going to cut that out. And you can profile your application's network traffic.
It's not only about like the external call that you can detect. There's so the network mapper, which is like an open source project. If you type the network mapper command, and in a parameter you type your namespace, it's going to figure out and draw up the whole communication for you. So it's going to generate the whole client intents, whether it's network policies, whether it's also work with Istio as well. So if you have any Envoy proxy, we're going to monitor the Envoy proxy to go at layer 7. So here, of course, we are network policy, so it's layer 3 and 4. If you want to go layer 7, so probably you're going to use Istio. Then we're going to monitor the proxy, the Envoy proxy.
So by layer 7, you mean the HTTP, the URL paths, basically, that you're accessing?
Correct. So we're going to monitor the pull the metrics from the Envoy proxy regarding the HTTP, access and HTTP requests. Then it just becomes like the lower level interfaces. The higher level interface is the client intent. This is what you care about. This is as a developer. And the goal is to reduce the friction again. But then the lower interfaces are just integrations. You don't really care about it. It's more like the open source community working on those interfaces and implementing them. So today, as I mentioned, we have AWS, we have Google, we have Azure, we have network policies, we have PostgreSQL, and we have integration with GitHub as well. So the idea is monitor a namespace or multiple namespace with applications. You have the base client intent that you have applied. They are staying into your GitHub repo or your Git repo somewhere, like in a GitHub sort of approach. If the system detects that there's a new application communication pattern that is emerging, then the system is going to do a pull request and create a new client intent. Then you can merge the pull request, or you can just, okay, no, it was just like a mistake or something. I don't want to apply that. And once it sits in your repo, then the single source of trust then becomes the repo, and then you can use GitOps workflow to apply this into Kubernetes, so to keep this security chain from end to end with the least privilege principle from end to end.
You can see an evolution of the concept here, like in Kubernetes, where you don't really want to go and build an individual pod because it might change, it might break. So you build something with a controller, maybe a replica set, something like this. In the same way, you don't really want to have to manage individual network policies. So you've got a helpful abstraction on top of them that figures out how to create the network policies to do what you want to happen, in the same way as your replica set or whatever creates pods in the way that achieves your outcome. You've stated an outcome, and all of a sudden the system's helping you.
This is exactly the inspiration. We're gonna have, in technology, we have to take a look at what is working and replicating that into other domains. With Kubernetes, exactly what you mentioned. We have the higher level controller. We have the deployment controller that needs to figure out, how many replica in my replica set I need to maintain this high level, my desired state. Exactly the same thing here. What is our desired state? Our desired state is I need X to talk to Y. I need it to be secure, period. Figure out the rest. If it's in AWS, do that. If it's in Azure, do that. If it's like in Kubernetes, do network policies. If it's a database, figure it out yourself.
And it also stops people having to worry about lots of the implementation details in AWS. So you can just paper over the top and say it doesn't matter if that's AWS.
And there's two ways to apply that. You mentioned like sort of like a learning mode. There's a shadow mode where you can discover things. So it's kind of behaving as a ADM or application dependency mapping, tool. Or you can go the full, okay, I'm going to enforce this everywhere because I want it to be secure. So you can easily migrate from phase 1 to phase 2, but also in a gradual fashion, right? So, and we figure things out. We figure things out like if you put an ingress on top of that, suddenly your network policy tend to change because now you have the ingress talking to your backend, and you need to allow everything, to the ingress as well. So we do this kind of default policy that you don't necessarily think about. Same thing if you start to apply network policies. The first mistake I see people doing is if you want to create egress rule, like we mentioned before, what's going to happen? The first thing that if you create egress rule, so you give access to a particular website or a particular component, but people tend to forget that as soon as you do that, you have a default deny rule for everything else. And what is the first service you need in Kubernetes to be able to talk and discover other service? Is bloody DNS, right? It's always DNS. And you forget about that. So here what we do is, okay, there's a flag. Okay, we don't forget to still maintain communication to DNS, right? Don't cut the branch where you're sitting on.
I can see the application, like you say, with zero trust, where the perimeter is, you're not in a big safe box where all your application code can trust each other. You're in a box where there might be foreign application code in there that you don't trust, and where your application code may not reach the assets that it thinks it's reaching. So it's useful to be able to record like the IP DNS mappings and things as well. And
it's also, like what I like to call continuous compliance, because that's the problem between security and developers and the platform team in the middle. Sometimes, things get a bit too fast for the security team and they can't keep up with the innovation pace. And you have like lag between the moment where, you have something in staging that may be breaching some rules, breaking some security rules as defined per the security team. And then maybe the security team don't even know about it. And here, at least you stay constantly compliant with the high level sort of rule, which is keep this least privilege principle from start to finish, and this zero trust approach where by default don't allow anything but accept what you really need to make your application work, regardless of the technology you're using.
So earlier you were talking around there's some different open source components and there's different operators involved with this. Where can people kind of get started?
All those open source projects, they are hosted under the Otterize organization. But the simplest way to get started with is to go to docs.otterize.com, where you will have the description of every component, how you can install them, how they interact together. So we have essentially three components. We have the network mapper, which is sniffing, the traffic using BPF, not eBPF, but CBPF, because eBPF has its place, but here not necessarily we don't need eBPF. So CBPF, classic BPF, is what we use for the network mapper, sniffing, how applications are talking together, also doing this integration with DNS resolution. That's essentially that. Then there is the credentials operator that is going to generate credentials for, create the IAM roles in the cloud, in this external component, creating short-lived credentials for your Postgres database, for example. And then we have the intent operator, which is reconciling the client intent with the lower interfaces, basically ingesting the client intents manifests. So those are the three main components. And there is a command line, which is called Otterize network mapper. And then you can use this also open source. You can use the network mapper as a command line to create your client intent as detected by your network mapper. So you can either create the client intents like we see on the picture here, or you can also draw a JPEG format, a visualization, with this nice diagrams, who's talking to who.
I must say, I saw the visualization and my first thing was, oh yeah, this must produce a lot of data. It's going to be hard to visualize. I bet they've made all the visualization bits closed source and you have to pay for them. But no, you can just create an image. This is great. This is really useful.
Of course, we have a business model as well. You can connect this to Otterize Cloud classic model, which is also free to start with. You don't have to pay for everything. If you want visualization, you can just create an account. It's going to be free. There's a freemium sort of model like pretty much everything now. Of course, you're going to have a bit of added value. Of course, the visualization will be a lot better because imagine you have an application that is involving multiple namespaces, potentially talking to the Kubernetes, service or somewhere. Like it tends to grow super fast. You will end up with something you cannot really understand. Whereas if you connect your network mapper, your environment to Otterize Cloud, then you will see a nicer visualizer, and you can apply filters by namespace, by date, select some components, things like that. So of course you got this additional value, but the most of the value, which is the client intents, what is really happening into your cluster, all of that, you can start with just the open source project.
If you're going to a brownfield site, it's likely that people would have existing compliance frameworks. Maybe they're reporting data somewhere, hoovering it up and comparing it against some existing rule sets. So if you're going into a brownfield site, what type of integrations would you typically see with Otterize?
It would be a two phases approach. The first one, you're going to apply, Otterize in shadow mode. Shadow mode means that client intents are going to be there sitting for a while, but we don't actually create the lower security components. So you have the client intents, but we don't reconcile them with actual security mechanism. It's like a dry run, so you can understand what is needed by your application just looking at the client intents. So first, you have to understand, okay, is it matching what I have in my database somewhere in the security team repository, or is there something different then? So you have to figure out if you align with what already exists and reconcile that more from a process perspective. And then at some point, you can just turn it on by namespace, essentially.
In the past, I guess I grew up with role-based access control. We thought we were pretty cool because you could put users into groups and you could give permissions to users and groups. And then we saw kind of attribute-based enhancements of that still static model where you could say exactly like what attributes of cloud objects could be accessed and what specifically could be done by different teams. And now it feels we've seen an evolution into something more dynamic, more outcome focused, which is a theme with a lot of cloud native technologies. You've got a dynamic outcome focused model for access control.
You have this dynamic principle that allows you to stay compliant over time with your rules. But most importantly, it does establish a relation between you as a developer and the service, right? And sometimes I see people saying, yeah, but I don't want to trust the developer. Okay, but at the same time, if you have to think about your company as a whole, maybe you're providing like a Prometheus service. Everyone can access the Prometheus service. So it doesn't make sense to go request by request, team by team, or am I going to allow you to access my Prometheus server? Of course you will. So this is where the client intent makes sense. But maybe other cases where you have, okay, I want to access a service, I don't know this team, so maybe they will refuse to apply my client intent. It doesn't really matter in the end, because it's not because the developer is saying I want to access this that necessarily you want to allow them to access that particular service. This is why you can review the client intent and have this kind of GitOps approach where you put all your requests instead of opening a Jira ticket. You already propose your configuration, and because it's human, readable, then you can say, as if you're on the other side of the fence, and say, okay, I'm going to allow this or not, because you can just read that. So instead of using a Jira ticket and waiting for someone to do that, you can manage everything on Git, propose your client intent, a PR, someone validate the PR or reject it, and job done.
And conversely, when someone leaves the organization, you don't have to run around and put in loads of Jira tickets to clear up their access.
This is exactly the principle of intent-based access control, IBAC. This is this idea first of having this dynamic motion in terms of maintaining compliance, but also having the ability to kind of reverse the relation. I want this, do you allow me? Instead of having, okay, I'm the server, I'm allowing you and you, but not you. It's like reversed, because it is how you should do things. As a developer, you don't want to wait. You say, I want this.
So thanks, Nic. I think we've had an awesome discussion today. There's been some really good information around IAMs, IAM policies, how to get started with those. Have you got any kind of key takeaways for folks in getting started with this sort of stuff?
If you want to learn more, we have a lot of tutorials on the Otterize documentation website. So you can try this out, or just download the CLI, the Otterize CLI, where you will have integration with the network mapper and other policies, and try this out into your, one of your namespace, for example, if you have workloads there. I've wrote also a couple of very deep technical blog articles for the last couple of weeks, where I'm explaining those concepts. So one specifically on what we've mentioned today, the AWS ACK controller for DynamoDB, how to do it with, also with client intents. So yeah, check out the blogs, you can check out the docs. And if you have any questions, you can just join the Slack channel and ping me directly. I'll be more than happy to answer any question.
Well, this has been an excellent episode. Thank you very much, Nic, for explaining the modern attitude to authorization and access control, and how you can actually be secure without getting stuck down in the weeds. It's been fascinating talking to you.
Thank you very much, too. It was very, very cool, guys.
As always, if you're watching us on YouTube, don't forget to like and subscribe and all those things you do. Feel free to add some comments. We'd love to see your feedback. We can relay some of that stuff over to Nic if you've got questions for him as well. If you're listening to us on a podcast somewhere, then same way, kind of make sure you're subscribing. We'd love to get your feedback. Thank you very much, folks. Thanks, Nic. Speak to you again soon.
Thanks, Nic.
Thank you, guys.